Assalamu alaikum everyone. I'm making another tutorial for the parallel circuit of the first tutorial that I have made for the series circuit. Now I'm making for the parallel circuit. This is the manual that I'll share with you. We have the same resistors that we had in the series circuit, but this time these resistors are in the parallel configuration. Okay, and we have same thing. We have a DC power here, we have three resistors, we have ground source. We need to find the current in all the three resistors. This is R1, R2 and R3 in the three resistors. Okay, and what we need to find is the total current basically, the voltages across the resistor R1, R2 and R3. The thing that you need to remember and note down is that for a parallel circuit, the voltage remains same in the parallel branch. Like the voltage across R1, R2 and R3 will remain same. However, the current would be different, and the total voltage would be the sum of all the all the three voltages here. So we need to find the voltages across all the three resistors, which should be same, and we need to find the current across R1, R2 and R3. So how we will be doing this is, he'll open the multisim. I've created a snipping tool shortcut here of the circuit so that I don't have to go and fro. Same, we go to place, we go to component. Okay, we write here resistor and we select first resistor. Here's your second resistor and here's your third resistor. Three resistors that we have. The next thing we need is DC power. We select DC power, write OK here. And the last thing that we need is ground source, and here is a ground. Since we need to change the orientation of this, we select this, we'll right click and we'll change the orientation of this like this. Again, flip, rotate. Now what you need to do, you need to connect this circuit with the help of wire. Go here, go down. Here's one connection, here's the other connection. You need to find a node here, place schematic, find a node here, junction. You put it here, then you put the wire, you connect it. Okay, again go probe, no, place on schematic and a junction. Here you place a junction, you connect it like this. It's not connecting because we don't have a junction here, so we'll go again, right click, schematic, junction. We'll place a junction here. Now this will be connected with this wire. Okay, so again similarly we need to find a junction. We need to connect two more junctions. Here's one junction. I'll put it here so that we can, and then again schematic, junction, place it right here. Okay, so you connect your wire from here till here, it's connected. Connect your wire from here to here, then you connect your wire from here to here, you connect your wire from here to here. So this is, if I can just change this. Okay, that's pretty good. Just move it up a little bit. Now the voltage source that we have is a 15 volts, so we double click on this and we change this to 15 volts. The resistance R1 is 1 kilo ohms. It's fine, just move it a little up, move this thing a little up also. And select this and move this a little up. So what we have is 1 kilo ohm, then we have 1.5, so we'll double click on this one and we change the value of the resistance from here till 1.5 kilo ohms. The last we have is 6.8 ohms. Okay, we'll run this. Last thing, we have not connected the ground. connect it anywhere you want. The circuit is complete. You run the simulation, everything's working smooth, no errors. Now what we need to do, we need to find the voltage of this circuit. So here's one voltmeter, here's another voltmeter. So because I'm finding the voltages across all the three resistors at once. So you connect it, one here and one here. Okay, similarly this one here. It's not connecting. You connect it here, you connect it here, and this one here, and this one here. So all the three resistors being the voltage source has been connected. You select this one, put it here, voltage and DC. Okay, here's the second one, voltage, and here's the third one. All three are here. We run the simulation, and look at this. This is what the parallel circuit is all about. In parallel circuit, the voltage remains same throughout the circuit, and in series circuit, if you remember, the current remains same throughout the circuit. So in the parallel voltage, it is the current, it is the voltage that remains same, and for the series circuit, it's the for the parallel circuit, it's the voltage that remains same, and for the series circuit, it's the current that remains same throughout the circuit. So I'll stop the simulation now. I'm just since I need to I want to measure the current across this R1 resistor. So if you remember before, what we did was that we need to connect it in series, if you remember it correctly, in series with this circuit, so that we can measure the current that's coming inside this 1 kilo ohm resistor. So we'll connect it here. Okay, we need to break this wire. Okay, place this here. So one would be coming from here, the other will be connected with your. Okay, so I need to measure the current, so I'll set this as current, then I'll run the simulation, and it's giving me the answer is 15 milliamperes. So the current that is going through the 1 kilo ohm resistor is 15 milliamperes. In the same manner, you need to find the current in the 1.5 kilo ohms and in the 6.8 kilo ohms resistor. Add them up and tell me the total current that is present in this circuit. Okay, if you remember, in the series we calculate the value of total voltages by adding all the voltage across the resistor. In the parallel circuit, we add all the currents to determine the total current in the circuit. I hope this is easy and you can make this and complete the table. Here is the table that we need to complete. Okay, so you will complete this table with the help of simulation, all the table, because supply voltage, the V1, V2 and V3 will remain same, 15, 15, 15 everywhere. Yes, the main thing that you need to find is the currents, the I1 current, the I2 current and the I3 current. The three currents that are in the three resistors is going through the resistors. Then you need to find a total current. Total current would be nothing, just the addition of these three values. Total resistance, since this is a parallel circuit, so in parallel circuit the resistance is 1 over R1 plus 1 over R2 plus 1 over 3. This resistor thing I will explain you when you come in the class, but for now what I want you all is to complete V1, V2, V3 and complete I1, I2, I3 with the help of the simulation. See this tutorial. If you have any problem, feel free to ask me. Thank you so much. Allah Hafiz.